actually measuring the temperature of the sand about where the beer is. It's now at 66 degrees. It's gone down about a quarter of a degree since the fire started.
Maybe through some mysterious thermal exchange, the beer has become icy cold.
68 degrees, so it has warmed it up.
Or maybe not.
So this technique yielded a warm, gasoline-soaked, sandy beer. This is pretty much the very last thing I want to bring near my lips at the beach.
So the gas fire-cooled six-pack myth is busted. But maybe there's a better way.
I bet there's some really nifty ways to beer really quickly.
I would have to agree, but I think we should start by getting a really good benchmark as to how long it takes a normal six-pack to cool down, like in a refrigerator, in a freezer, in a cooler. So why don't we do a bunch of trials on a six-pack and see what the standard cooling times are.
So in hot pursuit of the fastest way to chill a six-pack,
Mom, I hate science.
we'll compare several methods. The fridge and freezer, of course. And some more party-friendly options. Coolers with ice and water, and ice, water, and salt.
I'm a colon.
Tell the difference between these two.
Adding
Mom?
salt melts ice and lowers the water's freezing point.
Yeah, I gotta say this one is more painful.
So you get much colder water.
Wow, the difference is really clear. The ice and water is 33 degrees. The ice, water, and salt is 24 degrees.
Well, I'll be darned. Chemistry at work.
Let's see what a baseline room temperature of beer is. What do you know? It's the temperature of the room. 62 degrees. That's exactly what we've got there.
They'll time when each method reaches drinking temperature of between 37 and 40 degrees, checking the beer's temperature every 5 minutes, in much the same way a thirsty partygoer might.
38 seconds. Okay. Waiting another 4 minutes and 20 seconds.
Which gives them just enough time to try a less conventional method.
I can't see a damn thing. Hold on.
This kind of fire extinguisher is full of liquid carbon dioxide under pressure. When it's released, it expands into a gas, cooling the air around it and forming ice.
All right, so it's been about 2-3 minutes here. Let's see how much it cooled this beer down. Oh, it feels nice and frosty. $37 degrees is actually a nearly ideal beer temperature.
If you do have one, and you're willing to spend maybe, $30 on having your beer cooled now, then I guess you can do that. It's fairly effective.
I'm sorry, what was that?
So 3 minutes to drinking temperature, fire extinguisher assisted. How are the other tests doing after 5 minutes?
5, 4, 3, 2, 1, go.
Popping out a beer.
Wow.
What?
Salt water, 35.9 degrees.
Wow! Salt water's done.
Yeah.
30. Wait.
The regular ice water, 44 degrees,
Okay.
and regular ice, 57 degrees.
Or how about cooler with ice? 57.
The freezer and fridge are at 55 and 60 degrees. So, party, if you've only got 5 minutes, salt water and ice is the answer.
So the ice and water and salt is done. We're done with that. Target temperature and a little bit more.
Science plus beer equals good.
As for the rest, the cooler with ice and water was next best at 15 minutes. Then the freezer at 25. Just ice took half an hour. And if the fridge is your only hope, maybe invite the gang back tomorrow.
Well, we got some not so impressive and some impressive times to cool down a six-pack. But the CO2 fire extinguisher beat everything hands down at 3 minutes.
Well, so Are we going to be able to improve on these with our own little inventions?
Well, that's our challenge. Can we build a device that can cool a six-pack down in less than 3 minutes?
Well, looks like it's back to the machine shop.
Time to get to work.
The Mythbusters Bill Jean is on the trail of a mystery. A strange